In this video, we will look at how attributes can be attached to geometric entities in Mobius. We would like to apply some color and materials to our models. Colors and materials are applied using attributes. So this requires you to understand the basics of modeling with attributes. Attributes are data that can be attached to the geometric entities. By default, all entities have an attribute that is their unique ID. This ID is generated automatically by the system. For positions, there is one additional default attribute. That is the XYZ attribute, which defines the coordinates of each position. It is a single attribute whose value is a list of 3 numbers. The attributes are shown in the CAD viewer, in the attribute table below the 3D view. The table has a series of tabs along the top for showing attributes attached to different types of geometric entities. Let's start by having a look at objects. Points, polyline, and polygons are objects. So far we have used polyline and polygons, but no points. Points are the simplest type of object, consisting of just a point in space. Each object also has a default ID attribute. You can add your own custom attributes to any entity in the model. The entities you choose to add is up to you. In this example, we have added an attribute to the polygons called stepNum. This attribute is the step number of each step. And an attribute called height. This attribute is the height of each step above the ground. To set an attribute value, you can use the attrib.Set function. The function arguments take an entity, an attribute name, and an attribute value. We can ignore the 4th argument for the moment. When this function is called, it will attach the attribute to the specified polygon. If it is the first time an attribute with that name is being set, then a new column will appear in the attribute table. To get an attribute value, you can use the attrib.Get function. In this case, the function arguments take an entity and an attribute name. If the attribute name does not exist, the function will throw an error. If it exists, the function will return the attribute value. When writing code, getting and setting attribute values is a very common operation. Mobius therefore provides a shorthand way of doing this. The shorthand uses the entity, followed by the @ symbol, followed by the attribute name. You can use the same shorthand for both setting and getting attributes. The examples show the 2 approaches, using the function versus using the shorthand. The first example sets the stepNum attribute. And the second example gets the stepNum attribute. Notice that when you are using the shorthand, you don't need the quotation marks around the attribute name. Now let's dive a little deeper and look at topological entities. When modeling with objects, you will often need to access some internal sub-entity in the object. For example, you may need to get one of the edges of a polygon. Topological sub entities define the internal structure of objects. There are 3 levels of topological sub entities. They are vertices, edges, and wires. Point objects only have a single vertex. Polyline objects have one wire with multiple edges and multiple vertices. Polygon objects have multiple wires, multiple edges, and multiple vertices. Let's look at an example of a polygon. For this example, the internal structure consists of 1 wire, 4 edges and 4 vertices. If the polygon had holes, it would also have a wire for each hole. Finally, the vertices are connected to positions. The positions are the only entities that store any information about spatial location. If the positions move, the polygon and all its internal structure will move with them. If you move a polygon, you are in fact just moving the positions. In the attribute table, there is a tab for sub-entities. If you select an object, This tab will show the sub-entities for the selected object. In the example, we have selected one of the steps, and then opened Sub-Entities tab. We can see that the polygon has a wire sub-entity. Under the wire, we can also see the edges, vertices, and positions. If we click on one of the rows for edges in the attribute table, then all edges for the object will be selected. In both the 3D view and in the attribute table, we can see the edges highlighted. If the edges had attributes, then they would also be visible here. Next, let's have a look at how to get access to entities using queries. A query is a request to find certain entities in the model. For now, we will focus on the basic query, which gets entities. The query.Get function can be used to get entities from other entities. For example, you can get the vertices from a polygon. In this example, you can read the function as saying, get the vertices from polygon 1. You can also get other entities from polygon 1. The drop-down menu in the query.Get function allows you to select what you want to get. If the value of the last argument is null, then the function will search the whole model. So in the example, the function will return all the positions in the model. You can read the function as saying, get all the positions from the model. As with getting and setting attributes, querying is also a very common operation. Mobius therefore again offers you another shorthand. The shorthand uses the entity, followed by the hash symbol, followed by 2 characters that specify the type of entity. The examples show the 2 approaches, using the function versus using the shorthand. The first example uses _v, which is for vertices. The second example uses ps, which is for positions. In the second example, no entity is specified before hash symbol. This is equivalent to querying the whole model. These shorthands mean that you need fewer lines of code to get things done. They will be used a lot in future examples and exercises, so it is good to get used to them as soon as possible. Now let's look at one more useful function that can be used with attributes. That is the attrib.Push function. You can think of objects, topology, positions and forming a hierarchy. The objects are at the top and positions at the bottom. Later, we will see that collections are above objects. And right at the top we have the model. But for now, let's think of objects as being at the top. The attrib.Push function can be used to push attribute values up and down this hierarchy. Let's look at pushing attributes using the attrib.Push function. The function has 4 arguments. The first argument specifies the source entity. It is the entity that currently has the attribute that you want to push. The second argument specifies the attribute name. The third argument specifies the destination that you want to push the attribute to. We can ignore the fourth argument for now. In this example, you can read the function as saying, for the pg entity, get the attribute with name step num and push it down to the positions. Here, you can see the function in operation. First, we create a step num attribute on the polygon. Then we push it down to the positions. And in the positions attribute table, a new column gets generated. Now let's look at a slightly more complex example, where we are pushing attributes up the hierarchy. In this case, we want to push the z-coordinate of the positions up to the polygons. This means we need to specify that we want the second item from the attribute named xyz. And in addition, when we push the attribute, we also want to rename it to height. All this can be achieved by specifying a list of values for the second argument. The first value in the list is the existing attribute name. The second is the index. And the third is the new attribute name. Here, you can see the function in operation. First, we get the positions from the pg entity. Then we push the Z value up to the polygons, renaming it to height along the way. And in the polygons attribute table, a new column gets generated.